In section 4.6, we'll find the equation of a line. We'll do this given some information. It could be a graph, it could be the slope and y-intercept, or just a generic point. It could be 2 points. We could be given a line and try to create an equation that is parallel to it through a specific point, or perhaps perpendicular to that line through a specific point. Part A. So if we're given the slope and the y-intercept, we can now create the equation of a line using the slope-intercept form, y equals mx plus b. Our first example of this is number 30. A line has slope -3/2 and passes through the point 0, -4. Find the equation of the line. Our first clue is the slope. M equals -3/2. We also know this line passes through the point 0, -4. Because the x-coordinate is 0, that means that this must be a y-intercept. Therefore, my b value will be -4. From here, we can simply use the formula y equals mx plus b to create the equation y equals -3/2x plus -4. We need to simplify this by removing adding the negative, and what we result in is y equals -3/2x minus 4. And I'll box this to show us my final answer. You try 49. A line has slope 6 and intercepts the point 0, 5. Find the equation of the line. Pause here. Try it on your own. I noticed that the point that was given had an x-coordinate that was 0. Therefore, this is a special point, a y-intercept. B, it becomes 5, and I'm given a slope of 6, so m is 6. Y equals 6x plus 5. And you try 50. A line passes through the point 0, -1 and has slope 10/3. Find its linear equation. Pause here and try it on your own. Here, y equals mx plus b is still a great form because we're given a y-intercept in the slope. Although I need to simplify, adding -1 changes into subtraction of 1 by 1. And you try 51, a line passes through the point 0, 3020 and has slope -22. Find its linear equation. Again, we're given a y-intercept, so we use the second coordinate, 3020, as my b, and then for slope, I replace m with -22. In example 31, we find the equation of this line graphed below. I see that the y-intercept occurs right here and would have a coordinate of 0, -3. To determine the slope, I need to find another point on this line. It looks like it may also pass through this point 1, -1. I can now find the slope. As I change in my horizontal direction 1, I rise 2. And now let's find a second point just to check ourselves. As I go over 1, I rise 1, 2. And it looks like this point right here is not actually on the line. So by checking this, I can see that this line is slightly higher than this point 1, -1. The next point that does appear to be on the line is this one, which is located at x of 4 and y-coordinate 6. So let's erase these other points and now find the slope of the line between these 2 points. My change in x direction, horizontal direction, was 4. And now my change in the y direction, vertical direction, was 3 plus 6, 9. Slope, m, equals change in y divided by change in x. Therefore, m equals 9 over 4. This y-intercept, 0, negative 3, tells me that b should be negative 3. And now I can use the formula y equals mx plus b and simplify to get y equals 9 over 4 times x minus 3. For you try 52, find the equation of this graph. How does your work compare to mine? I found this point, 0, 4, and the other point, 30, 2. Notice here my x-coordinates, the hash marks on the x-axis denote changes of 10. To find slope, I can create a slope triangle. As I change in my x direction of 30, and my change in my y direction was negative 2. Therefore, m equals delta y divided by delta x, which would be negative 2 over 30, which I then simplify to negative 1/15. This 0, 4 tells me that b needs to be the number 4, and I'd now replace those numbers into the equation, and I result in y equals negative 1 over 15 times x plus 4. Lines are one of the most basic ways we can model behavior. Example 32. Joachim deposits $200 in a trust every month, which his employer will match. It currently has $7,600. Express the balance in the trust B in terms of time, t, as years from the present. This may seem like a daunting problem, but we can break it down into some easier steps. First, we can check whether we really understand what's going on. So what happens this first month? Joachim deposits $200, and it says his employer will match that, so his employer will also deposit $200. So if we add $400 to the current balance of $7,600, it'll be $8,000 after the first month. In which order should we put these numbers? Should time, t, be first and balance, b, second? Or should we put b first and t second? As a rule of thumb, time is generally going to be my first coordinate, which would correspond to the horizontal axis. Another hint is in the last sentence. Express the balance in the trust b in terms of time, t, as years from the present. So to express b in terms of time, we need to say that b equals something to do with time. Because b is solved for in this equation, that implies that it should be the second coordinate. Recall when we were using the variables x and y, we generally like to solve for the second coordinate, y. Therefore, we're going to use this order. T is my first coordinate, b will be the second coordinate. Hopefully we'll be able to create an equation, capital B equals m slope times t plus little b, my y-intercept. How can we find the y-intercept? Well, we need to figure out what happens when t equals 0. Well, in this word problem, time is t, which is represented as years from the present. So if we are 0 years from the present, that would be now. And we know that the current balance in the account is 7,600. So when the time is now, t equals 0, capital B should be 7,600. Therefore, my little b, y-intercept, will be 7600. Slope is defined to be the change in the second coordinate divided by the change in the first coordinate, or m equals change in the balance divided by the change in years. In 1 year's time, so I move to the right one, how much will the balance change? I know that Joachim adds $200 every month, so that means that he would have added 200 times $12, and his employer also adds the same amount. Therefore, change in B would be $400 times 12, which would be 4,800. Simplifying this, we get m equals 4,800. Thus, we can model the balance in Joachim's bank account using the formula B, which is the balance, equals 4,800 times T plus 7,600. You try 53. What is the balance after 6 months and in 3 years? Pause here and try it on your own. Here's my work. 6 months is a half a year, so we need to figure out what B will be when T equals 1/2. We use the formula that we created, and we receive B equals 10,000. So after 6 months, there will be $10,000 in the trust. Now we solve this for when after 3 years, which would be T equals 3, we receive B equals 22,000. So after 3 years, there will be $22,000 in the trust. Make sure to use the correct units, dollars. In you try 54, Roberto has 10 tortoises now. Every 5 years, Roberto has 2 more tortoises. How many tortoises will Roberto have in 5 years? And in 10 years? This is fairly straightforward. If he has 10 tortoises now, and every 5 years he gets 2 more, then he'll have 12 in 5 years. In 10 years, Roberto will then have 2 more than that, which would be 14 tortoises. Can you write an equation that models the number of tortoises T he will have in terms of years Y from the present? Pause here, try it on your own, then check back with my work. Just like the previous example, time is generally going to be the first coordinate. Here, years, time, is should be the first coordinate. Also the fact that it says, write an equation that models the number of tortoises T he will have in terms of years. So that means that T should be solved for, and years should be somewhere on the other side of the equation. Also indicates that capital T should be the second coordinate. Hopefully we'll find an equation that relates T equals my plus b. We will have to pay special attention to the fact that y now is my first coordinate, when it usually is the second coordinate. So to find my t-intercept, the vertical intercept, we need to make the first coordinate y equal to 0. Y equals 0 represents 0 years from now, which would be the present. And currently, Roberto has 10 tortoises. So when y equals 0, t should be 10. Little b, then, is the number 10. All we now need to do is find slope. Slope is change in the second coordinate, which would be tortoises, divided by change in the first coordinate, which would be years. We know from this sentence that every 5 years, so that would be a change in y as 5, Roberto gains 2 more tortoises, so t would grow by 2. So for every delta y, or change in y of 5, Roberto gains 2 tortoises, delta t equals 2. Therefore, m equals 2 divided by 5. We can now place this into the equation, t equals 2/5 y plus 10. We should check this equation with our previous work, dealing with 5 years and 10 years. If we replace number of years y with 5, our result is 2/5 times 5, which results in 2, plus 10, would be 12. And in fact, in 5 years, Roberto will have 12 tortoises, is what we found out earlier. And in 10 years, Roberto should have 2 divided by 5 times 10 plus 10 would be 4 plus 10, or 14. And indeed, in 10 years, Roberto will have 14 tortoises.